we begin our STEM lesson, let's go over our I can statement so we know what the learning target is for today and what we're going to be doing. So we know we're on what portion of the engineering design model?
Brainstorm.
Alright, so repeat after me. I know I can.
I know I can.
Brainstorm ideas.
Brainstorm ideas.
For the design.
For the design.
Of my roller coaster.
Of my roller coaster.
Alright, so when you are brainstorming, what are the two things that you have to do? Yes.
Apply math and science.
Yes, you're applying math and science, but what are you doing on that sheet of paper?
You are labeling and you're drawing.
Alright, she says you are drawing and you must label. You also need to be able to express how it's going to work. So you draw or you can
Label.
draw, label, or what?
Draw label or
Right, very good. I'm like, we go over this all the time. Alright, draw or write. Alright, the second I can statement. I know I can.
I know I can.
Apply math
Apply math
and
and
science.
science.
When brainstorming,
When brainstorming
the design
the design
of my roller
of
coaster.
my roller coaster.
Alright. Alright, just give me one example of what kind of math you can apply. Let me hear from someone different. Joanna?
geometry.
Geometry. Because you do need to be concerned about the shapes and the angles of your roller coaster. Alright, what kind of science could we apply?
Technology.
Yes, of course, technology. That's separate. So I'm going to place technology here. But what kind of science content can we apply? Christian.
Force and motion.
Force and motion. So this is your I can statement. This is what you should be able to do by the end of the class period. All right, end it. Okay, guys, are you ready for STEM?
Yes.
Alright, so very quickly, let's go over the engineering design model. I know everybody's very familiar with it. We do it for EFAD and for STEM. But the first part of our engineering design model starts here, which is A for what?
Add.
Then what comes next?
Brainstorm.
Then,
Create.
then,
Design.
then what?
Evaluate.
Alright, so we've already kind of identified our problem and written our problem. What kind of engineer are we for this particular project? Yes.
A medical.
Not medical, that sounds close, but
Technical.
technical sounds close too.
Mechanical.
Mechanical engineer. So if you need to refer to your design briefs, you can go ahead and open up your binders to your design brief. Who would like to tell me what the problem is? What is it that we're trying to do? Yes.
We tried to make a
Look at your design brief, Sergio.
we're trying to make a fast roller coaster. A faster and two-track roller coaster.
All right, we're trying to design a fast two-track roller coaster that attracts customers, but what's special about it?
That it like
What about that ball? Yes.
it can't fall off.
The ball cannot fall off of the track. So you all are mechanical engineers where the ball cannot fall off of your roller coaster that you design. So before we get designing our roller coaster, as we move on to the brainstorm portion, we're going to review our brainstorm notes before we break up into groups. So everybody direct your attention to the anchor chart. Remember this from last week?
Yes.
Alright, so we are on the B for what?
Brainstorm.
Alright, when we're brainstorming, we must draw or
Write ideas for possible solutions.
Alright, so we're trying to draw a picture, try to draw like a blueprint of our ideas for our possible solutions. Our solutions would be our design. What are we designing?
A roller coaster.
3D roller coaster with two tracks, and the ball has to be in the track. The whole time.
All right, so he said a mouthful. We are designing a roller coaster with 2 tracks. What else did you say? It has to be fast.
And 3D. And
3D.
The ball cannot fall off.
And the ball cannot fall off. So you are drawing and writing about your idea. Okay, so we restated the problem. Let's go ahead and restate the problem together.
We must design a fast 3D 2-track roller coaster. The ball cannot fall off.
All right, so that's a very huge problem that we have here. But we're only going to be able to use what when we're designing?
Oh, nothing sense.
No, I mean like materials.
Possible material.
What materials are they? Look at your design brief. You need to be looking at your design brief. Christian?
A wooden chair.
A wooden chair.
Pipe insulator.
Pipe insulator. Pass me that pipe insulator. Okay, this is what the pipe insulator looks like.
Oh.
This is part of the materials that you're going to have to use to make that roller coaster. What else can you use? Nicole?
Pipe cleaners.
Pipe cleaners. You have all of that in your buckets at your seats. Pipe cleaners. What else?
Material. Marbles.
Marbles. So that's going to represent that ball that we're talking about. Naisha?
Wood blocks.
Wooden blocks. And one more.
A cup.
And a cup. So these are all the materials that you have to use when you are trying to design this roller coaster. Alright, but as engineers, we must use what 2 things when we are thinking of ways to brainstorm and design? Math and science. So what science applies? What science?
Force, motion, speed, direction.
Well, let's say it together, everybody.
Force, motion, speed, direction, acceleration, friction, gravity, push, pull, position, velocity, inertia, and momentum.
That's a lot of different terms that you have to remember, right? But we learned about this when we were going over our science unit, and it all works together. But what tools could we use within the classroom to help us if we happen to forget what force is?
Computer.
We can use the computer, Marjorie.
Science word wall.
We can use the science word wall. That's a good one.
Science book.
In our science textbook. One more thing. Andy,
Notebook.
in your science notebook.
Oh.
Science notebook. Very good.
Oh.
But we also have to apply math. So let's read what kind of math we could be using as we're thinking about our roller coaster. And we talked about this last week. We can use what?
Measurement.
And within measurement, it's going to be what?
Weight, mass, length, and time.
Very good. But not just measurement. We have to think about how our roller coaster is shaped. And we call that what?
Geometry.
All right. And then within that geometry, we're going to think about angles.
Degrees, shapes, and lines.
Right. So would you want to have a straight angle for your roller coaster?
No.
No. So when you are thinking about your drawing and your brainstorm, this is not going to get that ball moving, is it?
No.
So you're going to have to think about degrees and angles. You agree?
Yes.
Good. All right. And again, what kind of tools and resources can we use? Yes.
A ruler.
We can use a ruler. Let's read it together.
Computer, protractor, ruler, science notebook, textbook, science word wall, math notebook.
All right. And then you might have some creative ideas. I know that some people have told me they have conversion charts when they're trying to convert their measurements. Whatever resources we have in the classroom, you are allowed to use them. Do I want you to go on the internet and look up how to build a roller coaster? No. This has to come from your own brain. These are your ideas. So if you use the computer, you must ask for permission. And I just want to make sure that you are using it to maybe look up force or motion or maybe some things about measurement, okay? Or any other kind of math that comes to your mind. Yes.
Or like, can we watch like pictures of pictures?
That might not be a bad idea. If you want to look at some pictures of roller coasters, I don't think that would be hurtful. But we are going to be using this website that I'm about to introduce to you. But before we move on to the website, let's look at the example that we came up with last week. Now you have your blank sheet of paper where you're going to draw that large piece. Let me see yours. That large, instead of those squares that we used to have, we're just going to do it on one side. It needs to have your name, so he has C9's brainstorm idea. Okay, okay, that's the team side. You are a step ahead of me. So this whole sheet is going to be for C9 to draw a very detailed brainstorm idea. So instead of that small square that we usually have, you're going to have this whole sheet. You can use colored pencils. You can use what else? Crayons. Not markers because they bleed. Just pencils, rulers, and we're going to make it look neat, right?
Yes.
But what's the most important thing that you see about this brainstorm that we have up here? Jennifer? Well, how do you know where the ball is located? What have I done? How do you know where my ball is? Point to the ball. Right here? How do you know that's the ball? Other than the fact that I'm a fantastic artist, how do you know that's a ball? Because I labeled it. Yes, we have to do what? Label. You must label. Many of you are very good artists, but in order to be thorough and detailed, you need to label each and every object. Not only did we label those objects, what else did we label?
The steps.
The measurements.
Yeah, okay, so we use colors to show that the steps, what steps, how is it functioning, right? So here I wrote that I was going to apply force. What kind of force did I say I was going to apply? A push. And then that push was going to cause a what? Chain reaction. And then that chain reaction would make the dominoes fall and the CDs fall, and then ultimately the ball would fall into the what? Cup. And the reason that it's so easy for you to read is because I have labeled everything. Not only did I label my objects and then showed you what kind of science was in my picture, I showed you what? My measurements. Because if you draw a block and you don't tell me where it's located in the classroom, if I come behind you, I should be able to look at your brainstorm and build it, right? But if you don't tell me that it's 2 inches apart or 5 feet apart, I can make it wrong. So for a contraption like this, would it have made sense for it to be 3 feet apart? No, why not? If my block was here and my domino started here, then what would have happened?
The block will push the domino.
Yeah, the block was too far away from the dominoes. So you would have to have a shorter distance. So when you are making these brainstorms, I want to see how you thought about measurement. Alright? Alright, so here's the cool part. And before we move on, because I almost forgot, flip your paper where it says Jennifer's brainstorm idea. I want you to flip. Oh, everybody's ahead of me. On the other side, it should say what? Team's brainstorm idea. Because when you have your great idea, and everybody has their great idea, we're going to have a meeting with our teams, and we're going to collaborate and share our ideas with our team, and you all are going to decide, do you like one person's and you want to build that one, or would you like to use different ideas from everyone and make a different roller coaster? So you all are going to have to spend a good amount of time coming up with a very detailed roller coaster. And we're almost going to break into groups in just a moment. But before we do that, I want to introduce to you the website, because I have the laptops and the computers pulled up on a special website to help you build your roller coaster. So within your guided portfolio, it says that you have to use this site. This is the site. It's called Discovery Kids. Discovery Kids, and it's a game called Build a Roller Coaster. So when you go to your this roller coaster. Now, our roller coaster has to have how many tracks? 2. You have to choose your tracks from this website. There are 1, 2, 3, 4, 5, 6, 7, 8 different tracks that you can choose from. So whichever ones that you like, that's what you can use, okay? Alright, so let me show you how to use this website. When you click on one of them, it will give you the name of that track. So what do I expect you to do on your brainstorm?
Label
it. So let's say I want to use the large loop. I'm going to click on that large loop, and I'm going to drag it down to this track, and then it'll show me how that looks, right? Okay? You do the same with whichever ones you want to see. And then when you're finished, you can submit the coaster and it will show you how it looks. Okay, so let's just go and look at all the different ones they have. They had the large loop, they had the corkscrew. Here's the corkscrew, that's what that looks like. What is this one?
The boomerang.
Boomerang. This one is your
Large
camelback. That one looks very fun and scary. What about this one?
dip.
The dip. Alright. What about this one?
Bank
Bank curve. And you can bring it up here. I thought it wrapped around, but I guess that's enough. So then you have your bank curve. What's next? Tunnel and your bat wing. Okay, so when you're drawing, look very closely at how differently these look because you got to have a very good picture. So I'm going to submit the coaster. Oh, it's saying it's not complete. Okay, so I'm going to add the tunnel and the bat wing and another bat wing just to finish it out. And now I can submit my coaster. So you know that you only need to have 2, but just so that you can see that roller coaster, you can submit it. And it shows how people are going through. It's coming around. Alright, so it's telling me the fear meter was like, it's about an 8 out of 10. That was a very scary roller coaster. Okay? So before we move on, you know how to use the website. I have grouped you with some different people so you can get to working with a different group of people. So your mechanical engineering STEM group are as follows. Team 1, and I'll dismiss you by teams, okay? Team 1 is going to be Sergio, Marjorie, Brandon, and Leslie. You all are going to sit at team what? 1. Okay, very good. Team 2 is Christian, Naisha, Nicole, David. Team 3, Jade, C9, Daniel, Diana, and Jack. Team 4, Jose, Joanna, Eric, and Emily. Team 5 is Marcia, Andy, Jennifer, and Kevin. Alright, so when I call your team, quietly get up and transition over to your groups. Team 1, you can put this insulated. Team 2. Team 3. Team 4. And team 5. Alright, so what I expect during this time, you are really working independently at this time because you are not collaborating with your group yet. You need to come up with your own idea. Let me turn the lights on. All eyes on me.
All eyes on you.
You are coming up with your own idea. Once you finish with that, we're going to have about 2 days for coming up with your own idea. Then you're going to collaborate and meet with your group. So I have 1 laptop at some tables, 2 laptops at other tables. Then I have 3 laptops in the back. So what you can do is if you need to see that website again and you don't know maybe you want to use the corkscrew but you want to try it out again, you can go to one of those computers. You can pull out your science textbooks now. If you look on your table, I have your materials, the pipe cleaners, the pipe insulators, the protractors, colored pencils, marbles, anything that you would like to use. If you would like to go to a different part of the room, you can do that. You are working individually. Are you working in a group?
No. Ms. Peele?
Yes?
Is Marjorie with you?
Yes.
She's being checked out.
Okay, Marjorie, we'll see you tomorrow. Alright, so go ahead, break into your groups. I'm going to be walking around and seeing what you're thinking. You should be able to explain to me why you're designing it that way. So the engineer that you are should be telling me why you're using, what kind of math you're using, what kind of science, why did you decide to use the corkscrew and not the dip, okay? So go ahead and get started. Thank you for asking. Are y'all using this together? Okay. Now you can either use it together or one of you can go to the back and use it. Make sure you're on the right side.
I'm doing my part. Okay, now we do this. Now? have that one.
Okay, so that's for the what? We're building a Kevin. What are we building? A roller coaster. This is a contraction. So erase that. And no, you got the whole page. You don't have to use just a small corner. Just use the whole page, okay? So you all, if some of you need to go to the back computers, do that because it's only one computer. Brainstorming paper. You gotta have it out at all times so that you can take notes. Okay. Does anybody not have a computer right now that they need? Okay, because I have the smart board open. You want to use the smart board? It's hard to see when the lights are on. You can press try again. You all can music. Move the computer. You don't have to stop talking like this. So you did all. What kind of track did you choose? You need to know. What is that? What is this?
Oh,
That's the bat wing? Okay. So as you're using this site, you're not just playing the game. You are trying to figure out which 2 tracks that you like the most. Okay? Yes, ma'am.
we need
Everyone can still see?
Yes.
So use the tunnel.